This problem is no different than the ones we've been doing. Find an equation of the function that has this derivative. If this is our derivative, then what we're really going to be starting with is the indefinite integral of x squared e to the negative 2/10 x cubed power dx. It has one more thing to it though. Once we find the function, remember we have an indefinite because of that plus c. We're going to use this information to find the specific function that we're looking for. Okay, same thing. Do we see a composite function? And if you look at this, I think you probably have already picked it out. This is your composite function. So we're going to let u equal negative 2/10 x cubed. Take the derivative with respect to x. Negative 6/10 x squared. And if you look up here, you'll see that we have an x squared dx. If we multiply both sides by the differential x, I almost have exactly what I want, but I need now to divide by a negative 6/10. And then I will have that exactly. We can clean this up a little bit. This would be the same as negative 1 divided by 6/10. 6/10 is the same thing as the reciprocal, 10/6, which is the same thing as negative 5/3. So we really have negative 5/3 du is the same thing as x squared dx. So let's go back to our original problem. We're ready for our first substitution. And we will make this the indefinite integral of e to the u times negative 5/3 du. Remember, x squared dx has the same value as negative 5/3 du. Looking at this, we can say it's negative 5/3, the indefinite integral of e to the u du. Once again, what function generates e to the u as a derivative? And we would have, of course, the same thing. Derivative of e to the u is itself e to the u plus c. And this now is our function f of u. We want to go back and we'll do our second substitution now. Make this f of x. So we have f of x equals negative 5/3 e to the negative 2/10 x cubed. Let's go back and make sure about that. E is negative 2/10 x cubed plus c. Now we would stop here with our answer, except it says that this function has a graph that passes through the point 0, 3/2. So now if it passes through the point 0, 3/2, we know that f of 0 equals 3/2 equals negative 5/3 e to the negative 2/10, and because our input is 0, 0 cubed plus c. So what we're trying to do is we want to find out what is that specific value of c. Now we have here e to the 0 power. All of this is going to equal 0. So if we have e to the 0, that equals some quantity, we're actually saying that the log base e of something. Let's start over again on that because we don't need to go into all of that. E to the 0 power is going to be equal to 1, so we have 3/2 equals negative 5/3 times 1 plus c, or that c is equal to 3/2 plus 5/3. We can change this into 6. And we end up with 9 plus 10 sixths, or 19 sixths. So what is the specific function? Well, the specific one would be negative 5/3 e to the negative 2/10 x cubed plus 19/6. Okay, looking at the next problem, this one is has a little bit of a twist to it, so we'll go through this very carefully, make sure that we see where that happens. Once again, do we see a composite function? And be right there, the square root of the function 2 minus x. So we're going to begin the same way. Let u equal that inside function. And then we take a look at du dx, and we would have negative 1. And if we look at multiplying both sides by the differential x, we would have this. Now, the twist is, if you look up here to the function, or to the interval, we can do the 2 minus x, and we'll make that to the 1/2 power. And then if we look at x plus 1 differential x, this quantity right here is not the same, and there doesn't look to be any way that we can make it the same as this. So on first glance, you might say, well, this can't be done. But let's do one more thing. I'm going to put this in a different color ink so we can see this. If u equals 2 minus x, then we could rewrite that for x. And we can say then that x is equal to 2 minus u. I have to give you a moment to think about that. If we add x to both sides and then subtract u from both sides, we would have x equals 2 minus u. Now, what I'm going to do is I'm going to well, first of all, let's go back and let's do the first substitution so we can see where some of this is happening. We have the integration, indefinite integral of u to the 1/2, but I don't have anything again for the x plus 1. So what I'm going to do is to make this, and I'm going to go back to my green pen here so you can pick up on what we're doing. In place of x, I'm going to write 2 minus u. So in place of x, that x right there, I'm going to write 2 minus u, and then we have plus 1 dx. So that looks like this. We have the indefinite integral of u to the 1/2, and then this is going to be 1 minus u quantity d. Well, let's go back. I made a mistake, and so we'll make this, instead of 1 minus x, this is going to be 3 minus u equals dx. And in place of the dx, so I'm going to erase that up here and erase that down here. In place of that dx then, I'm going to come over here and write negative du equals dx, or negative 1 du equals dx. So now I can write negative 1, I'll put negative 1 there, du. So we'll just put a negative 1 in here in case we go back and look at that and wonder where that came from. And so I have u to the 1/2, 3 minus u, and then negative 1 du. Now if we look at this, let's see, that negative could come out in front, so let's just pull that out in front. And if I multiply u to the 1/2 times 3, that would be 3u to the 3/2, well, excuse me, 3u to the 1/2, getting a little ahead of myself, minus u to the 3/2 du. Now we're doing all of this in order to get it into a form that we can then begin to work with just the simple integration rule. So this would be then, and again what we're going to do now is write the function, which would be f of u, and that would be negative 1, we'll just pull that out in front. The simple integration rules, remember, it's add 1 to the exponent and divide by the new exponent. and then minus, this is going to be u to the 3/2 plus 1 divided by the new exponent plus c. So we have -1. We would have 3u to the 3/2 divided by 3/2. To divide by 3/2 is to multiply by the reciprocal. Minus u to the 3/2 plus 1, that would be 5/2. Divided by 5/2. So again, to divide by 5/2 is to multiply by 2/5 plus c. So we have our -1. We would then have 2, because the 3's cancel, 2u to the 3/2 minus 2/5 u to the 5/2 power plus c. Let's do our second substitution and put this all back in terms of x. So we have f of x equals -2. Now u has the value of 2 minus x. So that would be 2 minus x to the 3/2 power. The negative times the negative is the positive 2/5. 2 minus x to the 5/2 power plus c. And one thing we could do would be then we got a 2 and a 2 minus x to a power, so I'm going to factor on a -2 and a 2 minus x to the 3/2 power, and that would leave me with, I'm taking all of that, leave me with 1 plus 1/5 2 minus x, and if I take 3/2, if I take 2 minus x to the 3/2 out of 2 minus x to the 5/2, I would simply have to the first power plus c. And again, we can check this by looking at our derivative of this quantity and seeing if we get right back to this derivative right there. Now again, the only thing we had to do or think differently, and this is not maybe something that you would naturally have thought of, we did everything the same way we've always done, 2 minus x, and we have 2 minus x. But we got to the point where we were left with a quantity that was not in the work that we have over here. And so in order to help us, because we want to have everything in terms of u, if u is 2 minus x, then x is 2 minus u, then we can make that substitution as well. So there's actually a second substitution that we did right up here. Okay, let's go on to the next problem. Actually, we're going to actually do move on to section 5.2, and I will tell you that a hint, you're looking for the extra credit, it is going to be on Blackboard. That's as far as I'm going to tell you right now. I'll give you the rest of it in our discussion of section 5.2.